Welcome, everyone. This is the AIMI Center Happy Hour panel discussion on language models in medicine. We're happy to have you here. We have a wonderful panel of experts today to talk about this very important topic. As you all know, healthcare is a team sport, and communication is really the lifeblood of caring for our patients. So as we build tools for life sciences, language is really key. And so this is an incredibly important area for us to be thinking about and talking about today. And as you know, we've had recently a really once in a generation leap in progress in how we analyze natural language with all these new tools, transformers. Bert will have a chance to talk about that a little later. And really, language is fundamental to everything we do. It's how we communicate. It's how we reason abstractly. It allows us to develop complex ideas, to build ideas across time and space. So we have a lot of great questions and thoughts today, and look forward to an exciting discussion. What I'd like to do now is introduce the panelists or have them introduce themselves. And then we have some questions for them to answer. I'll be asking them questions. We do have a chat going on YouTube. We will be monitoring that. Please do ask questions there at any time, and we'll have a chance to have your questions discussed by the panelists. So we look forward to being with you today. At this point, I'd like to have our panelists introduce themselves. So I'll just call each person out. Tina, why don't you go ahead and introduce yourself?
Sure. So Tina Hernandez-Poussard, I'm an associate professor in medicine, biomedical informatics, and I also have appointments in surgery, biomedical data science, and epidemiology at Stanford. Given those range of degrees, I have a broad range of expertise. My focus has generally been on using digital data to improve diagnostic, prognostic, and patient outcomes. We use a combination of machine learning and NLP and everything in between. So happy to be here today.
Great, thanks. Malia Yetizgen, welcome.
Hi, my name is Malia Yetizgen. I'm an associate professor in the biomedical informatics at the University of Washington in Seattle. There I lead the UW BioNLP research group. My primary research area is clinical natural language processing. In my lab, we do try to build high-performance text processing approaches to extract information from clinical narratives and use the extracted information for secondary use purposes. And I do research on a wide range of NLP problems from the very basic name entry recognition to relation extraction to negation, certainty extraction, coreference resolution, and dialogue processing. And we do this to enable the secondary use applications. Thank you.
Great. Rogier.
Hi, everyone. My name is Rogier van der Sluis. I'm a postdoc at the AIMI Center at Stanford, supervised by today's moderator. I'm mostly working on self-supervised learning problems with vision. So I'm super excited to hear about all the text and language things today. And as I think the future is going to be multimodal. So definitely going to hear more of that.
Great, thank you. And Belize Gunnell, nice to see you. Please introduce yourself.
Yeah, hi everyone, happy to be here. I'm a fifth-year PhD student at Stanford University in electrical engineering, advised by Professor John Pauly. My primary research interest is in representation learning for natural language processing and medical imaging. But being at Stanford and given the interdisciplinary nature, like in the university and across Silicon Valley, I had the opportunities to work on information extraction, graph neural networks, etc. as well, thanks to multimodality also. And I'm also interested in data efficiency and robustness of broader machine learning systems.
Great. And my name is Kurt Langlotz. I'm a radiologist and director of the Center for AI in Medicine and Imaging that's sponsoring this happy hour today. And I have my own lab that does natural language processing and computer vision work as well. So nice to be here with all of you. So let's get started. We've talked about the fact that there's been this revolution in text processing, and much of the work has been done outside of medicine on large corpora, Wikipedia, other corpora of text. And so I wanted to start just by thinking about the contrast between the NLP work that's been done outside of medicine and the things that make natural language work in healthcare different. Malia, what do you think?
So I'm coming from computer science background. And I was working on general domain NLP before I moved to this domain. And actually clinical language has so many unique characteristics, which makes us there's no scarcity of interesting questions. First of all, clinical language is extremely domain specific. Each subdomain within the medicine has a different language for themselves even. Which makes it a little bit interesting because they have their own language, their own reporting behavior. Clinical narratives are extremely jargon heavy and not written for lay people. It's mainly written for clinical caregivers, for other caregivers, so that they can just follow the trajectory of the patients. Besides that, because they are created during the patient care, they are very noisy. So depending on the note type, the notes may contain lots of copy pastes from prior notes. There are lots of misspellings, incomplete sentences, grammar, depending on the note type, there may be no grammar at all. Sometimes it may be just sparse, phrases everywhere. Some components of these clinical notes come from the templates, and they are mainly coming from the structured data. Some parts of it is written by the people through the EMR, mainly guided by the UIs. So it's kind of really noisy data. And from the perspective of content, these sentences, there are many text blobs between these notes, and there's lots of negation mentions because usually clinicians document things they observe and also things they don't observe so that they can come to a conclusion about the diagnosis. And it would be highly speculative with lots of hypotheses and also lots of hedge sentences sometimes. Co-reference is extremely common and quite implicit compared to other text types that I work with. But after all these difficulties, one thing about clinical notes to work with that makes it work a bit easy is that they are very, very structured. So they come with, because of the templates that are imposed by the EMRs, most of the clinical notes come with sections, and the sections usually tell a lot about the content of the sentences coming after the section header. So it's kind of it's very unique type of text, in my opinion, which makes it really, which results lots of interesting NLP questions.
Yeah, that's a lot. So as you've highlighted, there are many, many differences, and that has some implications perhaps for whether we can build these very large language models like GPT-3 outside. Belize, what are your thoughts on the distinction between health and non-health language?
Yeah, so first of all, Meliha, I think touched on a lot of great points. Basically she said it's very domain specific, noisy, and structure of the text is very different in terms of negation, co-reference. So I completely agree with all of those. So maybe in contrast, I want to touch on how the healthcare NLP is similar to broader NLP, and like what types of like,
Great.
other
Yes.
problems that like,
Yes.
industry and like academia is trying to solve, because as you might imagine, this is a very high impact application. This is not like sentiment analysis for like some random ad, right? So like we need to be like more careful with this. So I think there are like several analogies that I see, like biggest one being, so there's a big effort on modeling long-term dependencies, like document level, like relationships. And with these like large language models and GPT-3, for example, we see a lot of coherency and like repetition issues, although it's like getting the grammar correctly, for example, when you're trying to do like long form generation. Let's say you're trying to like summarize a document, like a radiology report or something. So this is an active research area in machine learning, right? Like, but like I think this is a great compelling application. Like this is more of a reason why we should do better with like understanding like longer range dependencies. So that's like one piece, I think. And the other piece, I think, which Medha also touched on, it's very so usually when we think of NLP, we think of like one-dimensional text, right? Like we say like, okay, there's some passage, but a lot of the information is like contained in like tables and boxes, which actually like reminds me of like information extraction problems of like document understanding, where it's a big active research area in the industry for like invoice pre-processing, mortgage document pre-processing, etc. And there, it's still like getting studied because like there are tons of different templates, which is I think is a good analogy for having like different templates like across like different hospitals or like health institutions. Like you can't like leverage decades of knowledge that like people built from like information extraction from like web pages or like whatever. You need to think about how you're modeling that can actually generalize to like different kind of templates. So I think that's another piece. Like how do we like model these like tabular and like visual and textual cues in a way that's generalizable across like different institutions? And I think the obvious like third one that like I'm sure like we will get to is like patient decisions are complex, and then it's not like just textual information. So I think, I mean, everyone talks about like integrating like world knowledge from like knowledge graphs, etc., which we have in healthcare with like ICD codes, etc. But I think there are just like bigger potential gains here because like it can enable big opportunity to advance precision medicine and generate predictions tailored to individual patients.
Great. Thank you. And with that, maybe let's move on from the broader picture of health versus other forms of text analysis to think about specific applications of natural language understanding, natural language processing in health. So in my world, there's a lot of experimentation on contrastive learning between text and images or generating text from an image. I know there's a lot of work on understanding what's happening in the electronic health record. There's ambient intelligence in terms of, listening to a clinic encounter, that kind of thing. Tina, can you tell us a little more about what you think are the key health applications or will be health applications of NLP?
Yeah, sure. And so this is a great conversation, and I think there's a lot of emerging opportunities where we're looking at for NLP to really help move forward the precision medicine sort of application. And where we use NLP a lot in our research is thinking about, how do we identify symptoms, maybe adverse events, maybe patient-reported outcomes that might not be captured with an ICD code or some of these discrete data. But say, for example, a patient comes in and might be taking a medication and, it makes them nauseous, or it makes them, they can't sleep well with it. And so they might change medication. So we might use NLP to try and go through these texts to identify, what are some of the things the patient's saying about medication or treatment related side effects, et cetera. So we can get into the nuances of treatment decisions and really thinking about it from, what is the conversation that's happening that's really identifying these different treatment options. So I think there's a lot of opportunity to look at, bringing in the patient voice and bringing in sort of the clinician's preferences also, because they will write down in the clinical notes, patient tried this didn't work, so we're moving to, treatment X. And being able to understand why they're moving to treatment X could be very important for discovery, for learning, and for improving quality and patient outcomes. Great.
Malia, do you have anything to add?
Sure. Actually, I work in the symptom domain a lot. So what we do, most of the projects I do involve risk prediction and also outcomes prediction, like risk prediction for certain outcomes. And in the symptom domain, for example, very relevant to what Tina described, what we are trying to do is, for example, pre-diagnosis, we try to detect patient-reported symptoms earlier and at the time of that point to calculate a risk calculation for that patient, having the cancer in near future or in advanced future. So, but for post-diagnosis, what we are trying to do is mainly try to manage symptom burden, associated with the cancer and also the treatments. And we try to extract the symptoms with details and also associate that with the treatment or the cancer progress. So it's really from risk prediction point of view, I have at least 5 other risk prediction projects ongoing right now. Mm-hmm. In all of them, information extracted from NLP is a really great predictor for better outcome predictions. So, but for the other domains, another very interesting domain that I started to work on 2 years ago is mainly try to understand what's going on between patient-doctor conversations and also translate that into some note template, mm-hmm. which may, there are 2 nice outcomes of this. First of all, it may improve the note-taking process, it may improve the time. And also because we are intervening in a different way, it may result more complete notes, because most of the time these notes are written later in the time and then some details are forgotten and such like that.
Yeah, that's kind of a grand challenge, you might say. That
it is
accomplish that. You've got less burnout from less documentation. You have more accurate notes. You have something the patient can take home with that they can go back and review. All kinds of advantages. It's a hard problem, though, isn't it?
Oh, it's a very hard problem. That's why it's so appealing, actually.
Yeah.
Because there are so many different layers of different difficulties associated with that problem. So another work is in the radiology domain. I do work on the incidental findings. So again, it's kind of risk prediction somewhat, because when we process in the large scale radiology reports, and if we see a really surprising result, we try to predict what the outcomes would be associated with that result. So from my own perspective, I see NLP use in any aspect of risk prediction, actually. Of course, we first try to predict any outcome with first structured data to see what the performance would be. But usually we see gains, depending on the outcome, of course. We see gains when we include information from clinical text. Mm-hmm. Another very important aspect of application, in my opinion, is that to try to create longitudinal summaries of these patients, so that you can create a full picture what's happening in these patients' lives in terms of rather than taking a look at one note. Mm-hmm. As Beliz mentioned, you see a sequence of notes and then you try to abstract what's going on out of that. So actually the applications are quite limitless in this domain.
Of course, there's been a lot of work on, I guess, what you would call phenotype extraction.
Yeah.
And do you find that that's the best way to approach a prediction problem, is to start with those phenotypes and then move to the prediction, or just to directly try to predict it from the text using one of these large models? This is a question for anyone.
Yeah, I think it depends on the phenotype on the other hand. Yeah. So if, like, for example, I do work on a lot on like pneumonia related or lung related phenotypes, and usually those are consensus definition, and some part of the diagnosis comes from the chest X-ray, some part of it comes from the other tests, and like it's a whole picture, right? So some information comes from the image. So it's a multimodal classification task, in my opinion.
Good.
Yeah.
Well, and we did receive a question from the chat, which I think is relevant to this discussion. Can standardized clinical reports, or templates, I guess you could say, improve knowledge representation and the accuracy of NLP models? What do you all think?
I'll take a stab at that, because we've been talking about that a lot. And I think it's important to understand, and this is one of the differences between health data and other data, is in the clinical reports, the clinician is really telling a story about this patient, right? And they don't know the outcome of that story. So we talked about this, they're writing something, well, they complain of this, but they don't have this, and it could be this. And so it's a story that they're creating that they go back to often. And so we've heard a lot of feedback about, the more structured and standardized we make these reports, the harder it is for the clinician to tell their story the way they want to.
Great point.
And so again, it goes back to this burden, and how do you give, it's the art of medicine. It's called the art of medicine for a reason, because it really is trying to understand all these different signals and clues to come up with a diagnosis. So the structure is important, but it does cause the burden for the clinician. So I think it's a balancing game.
I suppose it depends on the setting too. So I know, for example, in radiology, we have templates. If you're measuring the aorta, the dimensions at various points, it's nice to have that in structure. You have the same points at the same time. The measurements are clearly stated. But on the other hand, if you've got a complex patient story, you might find that the narrative is going to be richer and have more semantic content within it. Yeah. Anyone else want to comment on that? Delise?
Yeah, I just want to say, I think it can have benefits and some downsides, as people mentioned, but I feel like we shouldn't rely on that from a model building perspective. The analog would be, right, in your data set, you shouldn't always think all of the bounding boxes are correct. Maybe 10% of them are not correct, or or knowledge graphs, we're talking about this, most of them are incomplete and there are a lot of mistakes. So I think your model ideally, obviously it shouldn't be 80% wrong, but I think we should have an underlying assumption that some of that is missing or not standardized, etc.
Great.
I kind of think that a hybrid version would probably be better at some point. So some key information should be very structured, but then the clinician still has some space to tell his story about what he really sees, or things that could be the differential diagnosis, for example.
And I know in my world, radiology, that's the direction I think that things are going, where we have some increasing number of very structured templates with very clear terminology and ordering of information. And yet we still have the opportunity to dictate a narrative using a microphone and speech recognition. So that's a good model. And I think does give richer information. Okay, so let's now drill down onto one of my favorite areas, which is how text and images interact. So for example, we sometimes can achieve good performance by looking at how the text, whether the text and the image agree, or encodings of the text and the image agree, contrastive learning, or using things, entities that we might extract from text as weak labels for training computer vision algorithms. So Belize, do you want to comment on what you see as some of the key issues in image analysis and how that relates to text?
Rohir, do you want to go first, actually? I have some thoughts, but I'm curious.
Go ahead, Rohir.
All right. I think this is a super promising area, because we always complain about the lack of labels for medical data sets, and secretly we do have a lot of labels. They're just radiology reports. So we should either or EHRs or something else like that. We should definitely make use of those. And that's kind of what we see if we apply frameworks like Convert, for example, that work a lot better than contrastive learning with images only. So Convert uses both text and images. to create this representation. And it kind of makes sense because in the radiology report, the things that are relevant for most downstream tasks are available, and not much more than that. So if you do some contrastive tasks, you kind of make sure that the model really learns those things that are like seen in the radiology report. Instead of, if you would do the same thing with just images and you would contrast between, so in the typical contrastive learning framework, you would do two augmentations of like a slice of a CT scan, for example. And you would say this is a positive pair because it's the same slice, but it has so much information. It has the whole, like, it doesn't focus on the point of interest. So it focuses on the whole slice instead of on the anomaly that we're actually interested in. So I think that's like one of the key things that text is really good at, or at least it's a good representation of the things that we're interested in. And I seriously look forward to all foundation models that would include textual labels as a training source. The other thing is that, for example, we can also do weak supervision. With Checkspert, for example, we crafted like numerous labels from the text, which was rule-based back then, but still, it gave us a lot of like labels that we could train on, and we could create a larger data set than we would ever imagined if we had to do it by hand. So I think that's like, we finally can get to a stage that we can create large data sets, not ImageNet large, but larger than we're used to. So we can do useful things. And that's due to the combination of text and images.
Great. Others have comments about text and images?
Yeah, I'll chime in, I think.
Yes.
So I think contrastive learning, I mean, without a doubt, like has been proven like really effective, like in the computer vision domain and in the NLP domain. I think there's several interesting questions like regarding the health space. Like one is, so most of these methods are dependent on like how you augment the data, because like the real deal, like if you're familiar with contrastive learning, is like what you define as negative and what you define as positive, right? Like which like comes from the domain knowledge, like that like we should like talk to doctors and like clinicians about maybe. And it's not immediately clear, right? Because medical images are super different, like how you define that, and like how do you like also like labels, right? Like these tasks are usually like pre-training plus some like fine-tuning on the task, and like it's still like an active research area. Like how do you choose your pre-training task like general enough so that like you have like a decent downstream performance in the task you care about? And like labels are also more interesting. There are like multi-label scenarios. Sometimes like it's labeled some way, but then you look at the subclass and you see like something completely different. So like I think there are very interesting issues there. So and in terms of like combining image and text, like I think I'm going to draw like a parallel to like broader machine learning. I'm not like fully like in a lot of the areas, like we can say like this method, like transformers like work the best for like this, but I feel like in terms of like data integration, I think it's still an unsolved problem. Like what is the best way like that we like combine both, like other than like use the best model for individual modalities and like combine in the end. Mm-hmm. So a lot of questions there for sure, but high impact.
Yeah, good. Anyone else? I just want to make one comment about the weak labeling, which I think is a common misconception. Is people say, well, you know, the information you extract from natural language or a report is going to be imperfect, and that's certainly true. But we're not planning on using that to build our ROC curve and to test the accuracy of that computer vision algorithm. We're using it to create these very large training data sets, which are fairly robust to those kinds of errors. And we still do need a really nice, pristine test set to measure the accuracy, but that can be much, much smaller, just enough to build our accuracy measures. So that's great. All right, so let's move on. Malia mentioned earlier in her comments about the fact that the natural language can be quite different in different domains. And yet, outside of medicine, we see these massive models like GPT-3 that can do various disparate tasks, write, articles and sonnets, and do all kinds of tasks such as that. And so I guess the question is that the direction that we think that healthcare text processing is going? Are we going to be ultimately building some gigantic language model that contains every form of text that you see in healthcare, and that with some fine tuning is going to work for a wide variety of tasks? Or are we going to be developing smaller models that are tailored to individual tasks? So just generally, what do you think about this notion of foundational models and things like GPT-3 in health? So Rohir, I'll start with you.
Well, that's a super tricky question. I think at the moment we should build like different models for different tasks, because radiology reports, for example, are so different from text in the EHR, and we know that like the normal pre-trained BERT, for example, doesn't work really well on medical text, and so we do things like BERT, or like we pre-train them on PubMed, and still it doesn't give like perfect accuracy or whatever metric we're using on the task we're interested in. So I think at the moment we should really focus on like one subdomain, for example, radiology reports, and try to fix that first before moving on to this huge model. But I could definitely be wrong. I mean, GPT-3 is very impressive. They like can do a lot of tasks that I like wouldn't expect it to do. So it could be that a super big model will ultimately prevail. But at the moment, I feel like we have to start with the small things first.
Okay, good. Tina, what do you think?
Yeah, I want to build on that, because I think that Roger made an important distinction in that, you know, we have these small domains that we need to build on and really develop these programs that work. And again, in healthcare, we're talking about people's lives. We're talking about diagnosing diseases. We're talking about these very, very sensitive things we're developing. So I think we really have to be confident in the performance of our models in these particular domains, and ensure that they work before we start, you know, moving along the pace towards these GPT-3 models, for example. So I think that we're not quite there yet, where there's still a little hesitancy in using NLP for some diagnostic purposes, et cetera. And so I think we have a little ways to go before we think of these more, you know, foundational models. So that's just my personal input.
Yeah. Others, Malia, Belize, do you have comments?
I agree what already have said. So it's like we recently published a paper for the radiology domain, actually, where like we mainly, from a language model, you get the most benefit when you do a domain specific model. Like in the large scale, we trained our model with, I think, 4 million radiology reports from our institution. And it really generalized well to mimic radiology reports, the chest x-rays. But so and we did lots of other experiments with while involving other domain data and stuff like that, and we still gain. Right now, we got the most gain from the in domain. So yeah, there's, I think, like there's some benefits like for continuing to do experimentation, but we are not still there yet, in my opinion.
Okay.
Maybe I'll like say like a high level comment. It's gonna be like slightly hand wavy, but like maybe the answer is both, like in the way that like this like pre-training plus fine-tuning paradigm is the current recipe, right? Mm-hmm. But like 3 years ago, like we didn't know about that. Maybe the answer is we need to find a better way to like leverage these like really powerful foundational models, and the recipe is not like pre-training plus fine-tuning. And for that, I think we need to be also like, I mean, to your like previous point, like pristine test sets, right? Like maybe like we need to be better with evaluation. I feel like the bigger question is like, how do we ensure these, like, because it's like a bigger deal, right? Like if the model like makes a mistake, like how do we even like think about like better evaluating these, like maybe giving some sort of like uncertainty estimates, etc. Mm-hmm. So I think there are two pieces there. Like how do we best leverage, maybe it's not pre-training, fine-tuning, and like how do we best evaluate?
So maybe even just interpreting your comments that might be 3 stages. In other words, you have a massive repository of all kinds of text, and you use that to prime the model in some way, and then you focus it on the specific area of text that you're really concerned with. And then you have your evaluation set, which is very highly curated expert data. That might be a good model.
Maybe.
Yeah. Okay. Interesting. Great. All right. Any other comments about that? All right, good. So let's talk now about some of the downsides. So we've just talked about GPT-3. I think that has 200 some billion parameters. GPT-4 is going to have like 100 trillion parameters, something like that. And I don't know how many, kilowatts that's going to burn through to train models such as that. And then, of course, we've got the inequities in that only some of us have access to these large data sets. Maybe that's more true outside of medicine than inside medicine research labs. But and then issues of bias, all of those things. So what are your thoughts on the downsides? What do you think are the key downsides of NLP, and how might we address those? Malia?
So you summarized really well, actually. Cost of training and also hardware access to large data sets, especially like trying to build multi-institutional data sets is quite difficult because like HIPAA, we all have our own silos of data which we play with. But I'm going to touch base with another topic that actually is the main bottleneck right now, right? Like, which is the cost of creating a gold standard for evaluation and training. So like, suppose we have unlimited resources, right? Like, which we have up to a point, like every institutions are getting better with their data centers and like with their server spaces and things like that. However, like for a given phenomena, like to create a really solid gold standard so that we can train and evaluate like really well, right? Is quite expensive. Like, it's just like, it has like lots of bottlenecks and it takes months and months of effort to create like even a data set on, for example, social determinants of health. We are working on that, like for our most recent NLP challenge, actually. It took us like months. Like the main problem was like you have millions of nodes. If you randomly sample, suppose you have unlimited number of annotators hours, which you don't have usually. So like it takes certain amount of time to create one gold standard node annotated with a certain phenomena. And like, if you randomly sample that node, most likely the random sample will not give you content-rich documents. And then like you have lots of useless documents in your gold standard, which makes the task even harder because then you need more training data to reach to a like certain extraction point of view. So like it's kind of, this is one problem. So like mainly data sets like need to be sampled very carefully, because like if you randomly sample, you hit the undersample issue, like mainly the data imbalance issue. If you bias too much, then you end up with a really biased data set, which then the performance is not really useful again. So right now, like we are mainly building an active learning, really well-defined query function for every training set we create, so that we have enough representation of the underrepresented phenomena that we are looking for. So one good example is, for example, for social determinants of health substance use case, like drug use, right? So if you randomly sample, 90% of the sentences would say that no history of drug use, or like patient denies this or patient denies that. But like what you are looking really for is like sentences like, for example, patient prior IV DUI, recent cocaine use, for example. These kind of like sentences like need to be like sampled so that like you need to be increasing your content richness and to also create a really solid gold standard. And of course, like the test set and the validation set needs to be randomly sampled so that you would measure your performance on the true distribution. So this is one problem. Like I usually spend the most amount of time to create a really solid training and evaluation set so that our results are meaningful. The other downside of our work is, of course, data and resource sharing. So I want to create these really large models, of course, like, for example, I want to combine multiple institution data, right? And then just so that we can create perhaps more generalizable like approaches in the end. But right now, like, it's very, very isolated. Everything is very isolated. And so we are trying to do some we are trying to address that, of course, with the identification involving multi-sites in the projects and trying to train and cross-domain adaptation across different domains and such. But that is mainly right now the downsides of like NLP from the perspective of applicability for secondary use in the large scale, in my opinion.
Well, so that's great. Well, I want to ask you about de-identification just for a second. So I know at the AIMI Center, we've released, I think, 14 data sets. They're all images because we know very well how to de-identify images. Text is got its own unique challenges when it comes to de-identification. And do you think that that's held us back? And where are we in progress of de-identifying text?
So for de-identifying text, actually, like the performances are really promising. Right now, we can get like almost perfect performance in many of the PHIs when trained and tested within an institution. So the problem there, though, is like you cannot really clearly say we de-identified this data set 100%, and there may be some leakage. And then this unfortunately is a bottleneck, because then if you want to release a data set, you have to manually review whether the automatic de-identification was correct, which is a quite time-consuming task. So I think like with data user agreements and with some like relaxation of rules is the only solution to this problem.
It would really supercharge the field, wouldn't it, if we had more public data sets available?
Oh, absolutely. Yeah. So like we are releasing 4,000 notes like for social determinants of health data set. And the amount of time we spent on annotation was around like 5 months. But to ensure the quality of the de-identification, and de-identification was done automatically, by the way, and we use our own model, which was like its accuracy was over 98%. But the amount of time manually review and ensure that there was no leakage was at least 3 months. So it's only 4,000 nodes, which is like very small data set.
Tina, your thoughts, and also if you want to make a comment about biases that creep in.
Exactly. I was going to say I want to build on what's been said, because there's and so this de-identifying data is really challenging. So we've been having a lot of challenge about really thinking about the ground truth and how is our ground truth biased in different ways. And so we met with a group of computer scientists, and it was trying to like, we'll just crowdsource notes and we need to label from this diverse jury. And I'm like, yeah, no, we can't crowdsource our notes. It's not possible because of, we have protected health information. But when we think about labeling, so I'll give you our example. We're looking at depressive symptoms following chemotherapy treatment. And so this is something we're trying to identify prior to any adverse event. And so, who's labeling the data? So whoever's labeling the data, they come with their own biases. So they're thinking, are we having our medical students label these data for depressive symptoms? Is it a psychiatrist? Is it an oncologist? Because each of these different labelers come with their own biases and could influence the ground truth. And then you have these outlier cases. So if you have somebody who's labeling all of these data, and then the more notes they read, the better they get at labeling and the different decisions they're going to make. So thinking about in the context of sort of this labeling drift is kind of a very interesting research topic that we're learning about. And the more you have somebody to label for you, the better they get at it. But then you need this diversity, and so. And then the other piece is, for example, in our example with depression, we have an encounter between an African-American and their oncologist. And so the way they're describing depressive symptoms might not be the same way that, a a Vietnamese woman is describing her depressive symptoms. And so having labelers who are aware of the differences in the cultural differences and the way that these might be reported is really interesting. And also the level of expertise for how people are labeling. I think these are really important biases that are coming into our ground truth when we're labeling our NLP. And I don't think we have enough thought put into that. Because we're struggling to get anything labeled for ground truth as it is. And so really thinking about the diversity of the jury of labelers, I think is a really important topic that's kind of coming out and shedding light on some of the biases we have incorporated in these models that we need to be more thoughtful of moving forward.
Well, and you mentioned crowdsourcing. Do you think that if you look at ImageNet, for example, a lot of that was done through crowdsourcing. Do you think that if we appropriately selected the crowd, shall we say, with the right level of expertise and the right diversity, right understanding, that we could better automate the labeling? Not automate is not the right word, but accelerate the labeling process through a crowd?
Absolutely. And I think when you are able to crowdsource, you get the diversity, right? You get more diversity in the labelers, which gives you more robust, information. And so, but again, when we're looking at, and here's the perfect example, when you're de-identifying something, there's a sentence that always comes up, treated the mayor's wife. And so that's something that's not going to be de-identified with all the technologies we have, but it's really important when we're thinking about sharing this data, how we can deal with something like that. So I think crowdsourcing is definitely a way that we want to move into, but it's just a problem of that de-identification and the protected health information that's in the note.
Yeah. Would anyone else like to chime in on this topic? We do have a question from the chat. There's a lot of discussion about equity. What does representation in NLP training data sets look like?
Yeah, I can go ahead and take a stab at that one. And so I think it's like with all of our data sets in AI, right? There's a lack of representation in the data we capture. It's going to be dependent on who's coming to the healthcare system, who's talking to their clinician. I mean, we've done some work showing the more people talk with their clinician, which means the more notes they're going to have generated in the healthcare system, the better survival they have. Of course, that's not, it's a proxy for patient engagement, but it just goes to show there's a bias in the notes we're collecting. There's a bias in the people who are coming to the healthcare system. So the same biases that apply to AI and machine learning apply to NLP.
Yeah. Good. I want to do a little bit of a round robin at this point. And ask you, what's your favorite idea for something that's not yet fully explored that we think would be a productive area for this kind of research in the future? So start with you, Rohir. What do you think?
Well, I was thinking about some of the problems we still have in NLP. And one of the things is that I'm not from an English speaking country, and that's oftentimes overlooked when we create these NLP models. There's so much English data out there, but for other countries, especially for the Netherlands, for example, we have 17 million people. There's not a lot of notes in the hospital system. So how can we bridge this gap? How can we create models that also work on text that's written in a different language?
Yeah,
so I'm super interested in, and I think there's not a lot of research going on that front, mostly because it's very difficult to get your hands on enough data to start training. And something else I'm very interested in is the combination of visual representation of data and textual representations in the form of contrastive learning, but also in self-supervision in general to take the field further than that we currently are. Because I do think that's going to be a solution to the lack of labels we have for vision problems. And I think that's going to, change the game in the long run.
Great, thanks. Feliz, how about you?
Yeah, I mean, I alluded to this a bit like initially, and I think there's some active research in this area, but it's about like data integration in the sense that like, there's a lot of molecular data, drug interaction data, side effects, imaging, etc., right? Like, I mean, one step is like combining text and image, but then you can also like build like huge like graphs of patients that have like some sort of like connection regarding their, I don't know, like some similar nodes in like their medical ontologies or like similar drugs or whatever. I think this is like a big opportunity that's like a bit untapped to advance like precision medicine and like generate predictions like tailored to individual patients. Like it's going to take a lot of work to get there, I think, but I think it's very exciting. Yeah.
Good. Tina, how about you? Oh, did Tina freeze? There she is.
Oh, sorry. Yeah, sorry, I froze there for a minute.
Yeah.
And I just want to build on that. And I think that there's a great opportunity to move down this precision medicine path and this personalized medicine path where we can use NLP and other technologies to really capture patient value, patient goals, understanding, what are the patients, goals for care. Is it they want to have longevity, they want to have quality, they want to have the combination of those, and what are the risks and harms balances they're willing to take. And so I think we can use technology and NLP to better capture conversations between clinician and patient, better capture conversations between caregivers and the healthcare system, and just do a better job of taking a more holistic approach of healthcare options and treatment options.
Yeah, so to support shared decision making, so that you're really incorporating the patient's values and what's being done. That is a good one. Yeah. Malia?
So all my ideas already have been summarized. But what excites me a lot in this domain is like we do have extensive amount of data that talks about the history of a patient. Like it's not about one instant of time, but like a time series of data coming to that instance, which will be like very useful for risk prediction perspective and also patient outcomes. So this has been like an idea that has been contemplated and published a lot in the literature: patient summarization, patient timeline prediction, or like mainly creating these trajectories of time. But it's not successful. We are not there yet, like what in terms of our extractions. So that area is like really one topic that excites me a lot. Like trying to get a really comprehensive summary of a patient at a given point of time by using multimodal data.
Great.
Yeah.
And I'll tell you, I'll use moderator's prerogative here, and I have one of my own, which is that I would love to see. So when we're reading an image, an imaging study, we've got the entire chart as a kind of background clinical history. And often what we get provided as clinical history is fairly brief. And we'd love to have a better summary, maybe 3 or 4 sentence summary of what's going on with this patient and why they needed this imaging study. And I get why the people who refer those patients to us don't want to have to rewrite everything that's already in the chart as to the reason why they're getting the CT of the abdomen or whatever study it is. And so can we develop technologies that would summarize that in a way that's appropriate for me and others as radiologists when we see that patient maybe one time? Same issue happens in anesthesia, happens in the emergency department. We have these one-time encounters with patients. We have to rapidly learn what's happening with that patient. And I think that would be an incredible opportunity. Not a lot of training data in that area, but I think it would be a game changer for a number of folks. So the other area that I think is exciting is, although it's very difficult to make progress, and that is generating text from images. And, we've done some work in that area. The accuracies are not that great if you do it directly, using language models. If you try to structure it a little more, that gets a little easier, but that's a really interesting problem as well. Any reactions to other people's grand challenges here?
the thing you mentioned about like having a short summary about a patient,
Yeah.
I think that would be really, really great. But I also think that it would be great if we could search the EHR in a better way than we currently can, because sometimes you just want to look up whether some specific symptom is related to someone's past, like a patient's past, and nowadays we have to read the whole, at least in the hospitals I've worked in, you need to read the whole EHR to finally come to the point that you're interested in, and it takes a long time.
Yeah.
So if we could fix that. And the second thing that came to mind was that if you have like a description of an image, for example, a radiology report, I would like to see a cohort of people with a similar description, for example. So I could see what happened to those patients and what treatment that they get and whether they got better or not. So like creating a cohort of similar patients would be something you could do if they have similar textual representations. So that would be really nice.
Yeah, regarding your first point, the EHR vendors are getting better in terms of search, but it's, they're really quite a bit behind of just what we can do to search the internet, for example. Yeah.
Oh yeah, one of my PhD students actually research dissertation is that he's trying to do a question answering system, but the answers come from the EMR. Yeah. So it's in a question understanding so that the people can write lay language questions as they it's kind of interesting domain.
We have another question from the chat. Could NLP be used to normalize doctors' reaction to patients? Or maybe to reframe this, it's sort of like a sentiment analysis almost. Can we quantify whether certain doctors are under or overreacting to what their patients are telling them? So a kind of, some kind of an evaluation or feedback to physicians and how they react. What do you think?
I mean, we talk a lot about, doctors like me or patients like me. And I think that's something you could see, patients similar to the one you're seeing, these are the medications they were prescribed, things like that. I'm not sure if that gets at the question that he's asking, but I mean, that's kind of what comes to mind is there are a lot of comparisons regarding, patients seeing patients with these diagnosis codes, et cetera, are prescribed this or done that. But the oversensitivity to a diagnosis, I think it goes back to something we were talking about earlier when you talk about, cultural awareness and really being in tune with the patient, because one cue might mean something for a particular group of patients and it might mean nothing for another group of patients. So that's really hard to get at, I think. Yeah. And it's more about awareness.
And I'm reminded of some of there's been some work done on psychotherapy and evaluating whether it's an effective therapist or not. And you could imagine evaluating potentially, if you had the ambient intelligence where you're actually listening to the patient encounter rather than looking at the note, you could perhaps provide some feedback to the clinician as to how they're responding to the patient, not so much factually in what the therapy they're prescribing, but just how they're relating interpersonally to that person. That could be interesting too. That's a great point. Great question from the audience.
And just to build on that, there was a recent article about negative descriptors in EHR notes related to patients with particular by race. And so it was very interesting to see that there were the descriptions of patients not listening, and there was a strong association with race. And so I think that, these unintentional biases or whatever might come with us when we're writing notes and putting these information into the medical records. So Great. It's interesting.
Well, I see we're approaching the top of the hour. This has been a fantastic discussion with great panelists, a lot of good insights. Thank you for being here. Thank you, audience, for your questions through the chat. We really appreciate your interaction and participation. And thank you on behalf of the AIMI Center for being here for this happy hour chat on language models. Have a good afternoon, everyone. you.